Hello everyone, and thank you all for joining us today. My name is Benson Hoagland, and I will be your host for today's Groov Epic webinar. We have a lot to cover in the next 45 minutes, and we'll start by telling you a little bit about Opto, followed by the problems we see in industrial IoT systems today. Then, I'm excited to introduce you to our newest groundbreaking product, Groov Epic, including its hardware features and software capabilities. Then, I'll describe various scenarios where we can solve common nagging communication problems with Groov Epic's new features, then finish with a live demo. You are viewing a recorded version of this webinar. You may also request a copy of these slides in PDF format by contacting us at sales@opto22.com. Okay, let's get started. For those of you viewing this webinar that are new to Opto22, here's a brief overview. We are a California-based, privately held industrial automation manufacturer and software developer with over 4 decades of experience at thousands of customers all over the world. Our products range from simple solid-state relays to versatile industrial Internet of Things systems. And we've earned a reputation in our industry for highly reliable, mission-critical solutions backed by exceptional warranties and top-shelf support. But what makes us unique is our engineering philosophy for combining technologies from both IT and OT into an affordable and capable system that can be applied to your projects, saving time, money, and effort. Now, over the years, we've amassed a huge list of customers, both large and small, from all over the globe in many industries. Speaking of industries that we serve, you can see it's very broad, from manufacturing to process control, to buildings, to utilities like water and wastewater, and of course, OEM equipment. And our customers love our open architecture approach with our products, and especially love our free support with plenty of tools, documents, software, and services, all at no additional charge. Now, our customers also benefit from our recently launched Opto Training Portal, offering free online training any time of day or night on most of our products, including the Groov Epic I'll be showing you today. Okay, let's jump into why we're here. As engineers, we all have ideas. It's in our DNA to conceive new ways to do things, to create a better, safer, and more productive environment relative to our jobs. In automation today, there's a lot of talk about industrial IoT, machine learning, cloud computing, and generally getting more out of our existing systems, as well as building new systems that take advantage of recent advancements in computing capabilities. However, we also encounter significant challenges that hinder the pursuit of those ideas. In many cases, these obstacles can be traced back to numerous issues we must all deal with in order to move our projects forward. And in more cases than not, complexity, cost, and maintaining these systems are some of the biggest hurdles. Today's industrial IoT systems are just too difficult to put together. In fact, more time is spent trying to get these various systems to work together while continuously addressing major issues like security, software licenses, PCs, Windows updates, networking, and much more. And it was this pain that drove us to develop a new system that would address many of those challenges I just described. We wanted to build a single cohesive system offering edge computing, easy data exchange with other systems, mobile and web visualization, and much more, all combined with the real-time control and industrial I/O the industry knows us for. And we wanted to do this by significantly reducing the barriers to success by doing 3 things: dramatically reducing system components, embed security at every turn, and still perform at the highest levels. Indeed, we wanted to build a system that is simpler, more secure, and higher performance than anything else on the market. And we think we've done it. Introducing Groov Epic, the world's first edge programmable industrial controller. We asked ourselves, what if we could combine edge computing power with multiple programmability options, industrial packaging, and real-time control into a single platform? Wouldn't that be epic? Well, indeed it would be, and that led us to the birth of the EPIC acronym to describe our new system, an Edge Programmable Industrial Controller. So let's break this down. The E is for Edge, which is for collecting, processing, and exchanging data securely among databases, cloud platforms, even competing PLCs. And we do it where the data is produced at the edge of the network. And while we're at it, provide visualization of all of this data right at the edge as well. For the P, programmability was key, with many options to develop your control and data applications, including a method to run your own software. And for the I, legendary industrial hardness that Opto 22 has decades of experience building. And finally, for the C, a high-performance, open-source controller with truly state-of-the-art I/O backed by the same lifetime guarantee we've offered for years. That's Groov Epic, and we're mighty proud of our new baby. Epic is absolutely gorgeous, but don't let its good looks fool you. This is a remarkably agile, versatile, and powerful system. And it starts at the hardware, so let's begin with a tour of Groov Epic's hardware features. And of course, the place to start is where the physical world meets the digital world, the field termination. We custom developed our own removable terminal to provide time-saving methods to connect to your instruments, sensors, actuators, transmitters, and more. It starts with a simple and effective spring clamp terminal to make wiring a breeze. Then, for some modules, we provided 2 extra terminals for use as a common, for power rail or negative common, your choice. No more jumper straps. We've increased I/O density without resorting to off-module terminations and offer isolated and non-isolated versions of the I/O. We've even developed lower-cost, simple function modules when you don't need all the smarts we generally put into our I/O systems. But the smarts that remain in all of our modules is their ability to be automatically recognized by the controller and free to swap on or off the rack at any time. We've also loaded up our I/O modules with helpful multicolor LEDs to indicate module quality and provided LEDs for status of each discrete channel. Then we went one step further and added a touch-sensitive pad to each module. This is really cool. By simply touching the top of the module as shown here, the Groov Epic's touchscreen will automatically display all the information about that module. No need for a PC just to check out your I/O. While we are offering our most popular I/O module types at launch, we won't have all 100 plus modules offered in the Snap I/O line right away, but no problem. Snap Packs and Snap Ethernet I/O are 100% supported by the Groov Epic system, meaning you can use your existing I/O if you have it, or add I/O module types that are not quite available yet in Epic. Now, we made the system compact with the processor's touchscreen about the size of your smartphone, and are offering 4, 8, or 16 module chassis in stainless steel for unmatched ruggedness. Now, continuing our long tradition of using commercial, off-the-shelf technologies wherever we can, we've built the Groov Epic processor on industrially hardened ARM processors, the same processors that power today's smartphones, tablets, and other edge computing devices. Then, we selected open source Linux with real-time extensions to be the operating system. We've loaded it up with RAM and plenty of industrial solid-state drive space for your data-hungry applications, backed by a state-of-the-art power fail-safe file system to ensure reliability in the field. There's 2 independent gigabit Ethernet network ports, so you can segment your IT network from your control network, ensuring no one can access unsecure devices on the OT side of the network. And 2 USB ports for keyboard, mouse, Wi-Fi adapters, serial dongles, and more. Now, the Groov Epic screen is a high-resolution color touchscreen display rated for industrial use. It's absolutely gorgeous and beautifully displays your Groov View screens and your Groov Manage interface. And as hard as it will be to put this thing behind a cabinet door, we understand most enclosure doors aren't plexiglass. So we've included a built-in HDMI port so you can mount your own HDMI-compatible display and connect it directly to the Epic. No more need for separate, expensive operator interface terminals. We are providing numerous modular power supply options for AC power, DC power, and pass-through DC. And of course, the whole system is loaded with agency approvals, including Class 1 Div 2 for explosive environments and ATEX compliance. Now, configuring Groov Epic is a breeze with the built-in Groov Manage software. Let's take a tour. Groov Manage is one of the many software applications embedded into Groov Epic, and its purpose is to help you quickly configure, commission, and troubleshoot your new system without the need for a PC. You can use the built-in touchscreen or connect a mouse and keyboard to make your configurations even easier. You can also use any smartphone or tablet on the same network to configure the system. Of course, if you prefer to use a PC, you can. And any kind of PC you like, as long as it runs a modern web browser. The entire system is web-based. Now, the system is also secure right out of the box. Only authorized accounts are able to access Groov Epic through this login screen or over the network. Now, once logged in, you'll get to the home screen where you can access all the features on the system. There's also a handy top-level navigation to quickly jump to common sections. You can create specific user accounts for different individuals with unique rights to various software on the system. You can manage your network settings from here, the system screen, and again, without any special networking software or utilities, you have everything you need right here on the display. All I/O modules installed on the system are automatically registered, including discrete I/O, and the ability to check for properly wired inputs and test outputs right from the screen. Now this is cool. If you're wiring up a new module for the first time, we've actually embedded the wiring diagram directly into Epic. No need to go to the docs or the website. Everything you need is right here, including the specifications for every module. Analog is, of course, also covered, along with all the module's real-time data points. And that's a brief tour of Groov Manage. Next, let's dive into the application software found on Groov Epic. The software embedded on Groov Epic covers a broad range of applications. You may only need to use one or two applications like, say, Pack Control and GroovView to quickly create, build, and deploy your controls-related project. Or delve into others like Node-RED for quickly building IoT applications, or Ignition Edge for connecting to legacy PLCs like AB and Siemens. They're all there ready for your most demanding control and IoT projects. From a system architecture point of view, you'll see how Epic brings the OT side of the world to the IT side with the right connections, the right software, the right drivers, the right networking options, and industry-standard TLS-based security. And as we drill down to the software running on Epic, we'll come back to our software architecture diagram where I'll discuss one supported method of control programming with Pack Control. It's here where we create our tag database, and we create our flowcharts and scripting for our control strategy. Within Groov Manage, you can view the status and configuration of the control engine running directly on the Epic controller. Now, our free Pack Control software development tool has been around for decades, offering the simple elegance of flowchart-based control with up to 64 simultaneously running charts, plus sophisticated scripting for advanced programmers, all coupled to a real-time visual debugger. Now, support for analog, digital, and string handling remains, plus PID control loops and arrays of many types. However, there continues to be some demand for programming controllers with an IEC 61131 compatible language. So we've partnered with Codesys to offer their Codesys Workbench and runtime engine in Groov Epic, which will be available very soon. But what's very exciting and what sets Groov Epic apart from all other controllers on the market is optional secure shell access, or SSH. Imagine an edge programmable industrial controller with complete secure root access to the operating system and all the peripherals like the I/O, using your favorite programming language like C or C++, Java, Python, and many more. If you're an OEM, system integrator, or have otherwise developed your own software for your application, now you have a place to run it. Next up, GroovView, which is used to develop and view mobile and web interfaces for your Pack Control strategy, or for connected PLCs or other devices on the OT network. As you would expect, any screens you develop in GroovView's build mode will be beautifully displayed on Groov Epic's touchscreen. GroovView is server-based and secure, with all communications over HTTPS. You need only a web browser to build your screens, and your finished pages will be automatically and gracefully scaled to any size screen you use. There's a library of pre-made gadgets for you to work with, and virtually any graphic image of any type is supported as well. And anytime you've made a change to any screen, your users will automatically be updated. There are many other features in Groov View, including events, trending, messaging, and much more. We also offer Groov View on our Groov Edge appliance or Groov box and on our Groov server for Windows, so your projects will work on any of these platforms. Here's a few sample screens made with Groov View, and these are all available for viewing live at our demo site, demo.groov.com, with the credentials you see there at the bottom of the slide. And this is how those same screens look on the Groov ATEX Color touchscreen. Amazing. Next up is Node-RED, an open source builder environment and runtime embedded directly on the Groov ATEX system. Here's Node-RED through the Groov managed screens, so you can start and stop the runtime and view information about Node-RED status. So what is Node-RED? It's a browser-based data flow programming tool developed by IBM and now open source for all who wish to use it. Node-RED was developed to make it much easier to work with data, including connecting to web services for, say, like obtaining the current weather, or to connect to databases like SQL Server, MySQL, Postgres, or any other database, either locally within the plant or in the cloud. In fact, there are built-in nodes to connect with cloud platforms like Amazon IoT, IBM Watson, and Microsoft Azure. Even connections to business systems like SAP are supported with Node-RED. Now here's an example of a Node-RED data flow that gets the current local weather from a Weather Underground API call to a web service, and then makes that data available to your control program or Groov View screens. And here's one that collects operational data from connected wind turbine controls and I/O and sends the data directly to a relational database on Amazon RDS. Very simple, yet extremely powerful capabilities. Finally, we round out this ensemble of application software with Inductive Automation's Ignition Edge software. In this diagram, you'll see how Ignition Edge facilitates the connection to legacy PLCs and other devices that may exist on the OT network. And here's the Groov Managed screen for managing your Groov Edge instance running on the ATEX, whether it's running or not, and access to the Ignition Edge designer. So, what is Ignition Edge? It's software developed by our partner, Inductive Automation, the leaders in open, scalable SCADA software that's taken the industry by storm. They've created a version of their successful and very powerful Ignition platform and designed it to work at the edge, again, where the data originates. The primary capabilities of Ignition Edge that we use in Groov ATEX are twofold. One, they're built-in drivers to other PLCs. And the most popular legacy PLCs are included. For example, the Logix family of PLCs from Rockwell Automation Allen Bradley are in there, as well as their SLICs, PLC5s with Ethernet, and even Micrologix. On the Siemens side, the S7 series is covered, and for Schneider PLCs, or any Modbus compatible device, Ignition Edge has got you covered there too. And as one would expect, our own controller drivers are included as well. Now the second primary capability that Ignition Edge brings to the Groov ATEX system is the next generation of industrial communications using open source technologies like MQTT and Sparkplug. So, what problem are we trying to address here? The current state of affairs in industrial communications is fraught with challenges. The primary issue is that applications are too tightly coupled to devices, and a pull response mechanism is used for all data transfer. This makes creating, managing, and maintaining these systems very difficult over the term, not to mention the cost and expertise required of putting them all together. The other major challenge is the security vulnerabilities present in these architectures. Each connection between an application and a device tends to be specific to each, meaning several network ports must be open and maintained. In these types of systems, heavy IT involvement is generally required, which also means a lot of time on the phone with IT folks to get approvals for network addresses and ports, LAN management, and generally just getting everything to work. We think there's a better way. If we can decouple applications from devices, we're halfway there. What does that mean? Well, rather than the tightly coupled architecture we saw previously, a message broker architecture frees each device and/or application to publish its data or to subscribe to data it cares about when it's needed. And a bidirectional outbound publish-subscribe model vastly improves performance, as data is only transmitted on change, and subscribers are sent new data when that data changes. Network utilization is nearly an order of magnitude more efficient in this model. But some of the best news? This architecture is far more secure, with all connections authenticated and encrypted. Only one secure port is open in the entire system, and only one place to manage user and data access, at the MQTT Broker. You end up with a much simpler system to manage and maintain, and most importantly, significantly reduce your reliance on IT. So in summary, the MQTT transport and the Sparkplug topic and payload definition spec help build out industrial communication architectures with three primary benefits. Number one, simplicity, by building your network from the edge out over just about any kind of network, because data originates at the edge and the tag types and names you define during the control strategy creation become the single source of tags. Two, security, as all outbound traffic is authenticated and encrypted with standard TLS encryption and a single centralized place to manage security profiles at the MQTT Broker. And three, high performance with efficient payloads, low overhead, and publishing on data change only over these persistent connections. And with Sparkplug, you always know the state of every tag in the system. Now, there's much more information on open source MQTT and Sparkplug out on the web and certainly on our own website, including our blogs, helping you to learn more about how this important technology can help you. And in just a bit, I'll demonstrate how all the pieces come together in the live demo. But first, let's take a look at how these technologies can solve nagging communication issues in various automation scenarios. We'll focus on just three for this webinar: managing remotely deployed OEM equipment, collecting MES or OEE data within your plant, and finally, acquiring data from multiple locations back to a headquarters site. First is our OEM, Acme Ovens. Now, they build heavy-duty ovens that get deployed to customers all over the globe. Now, Acme would love to provide additional services to their customers, including predictive analytics, maintenance, and remote support. So all they ask is for their customer's IT department to open a port in their corporate firewall, permitting access to their network and ultimately access to their oven's control system. Yeah, right, not gonna happen. So what to do? How about applying open source MQTT and Sparkplug and publish the data from the oven on an outbound secure connection directly to an MQTT broker? MQTT brokers are just a software application that can run on a server back at Acme Ovens or in the cloud, like on Amazon or Microsoft Azure servers. Oh, and you can also download MQTT brokers like Mosquito free of charge, or use an MQTT broker service like HiveMQ. Lots of options for sure. Now here's a scenario for getting your production department MES or OEE data from many disparate automation lines within the four walls of your plant. The problem is, various control lines within a given plant may be placed on different network segments because IT had to build VLANs or put firewalls up to limit access, or maybe segmented the networks to reduce the chance of unauthorized access from the corporate network. These all pose big problems for getting the data out of these lines and back to production. However, with the application of MQTT and an MQTT broker on site, you can set up each line to publish its data on change, and the production department simply subscribes to those changes. And our final scenario, based on an actual application, is obtaining data from many geographically dispersed locations of a large multinational corporation. In the actual case, this customer had to hire expensive networking consulting companies to help build complex pole response networks over leased circuits, metropolitan area networks, VPNs, and more, just to get the data from the remote sites. And in most cases, the remote sites didn't have the required IT staff to facilitate these connections. In fact, some of these locations were outside of the US with no IT staff at all. So what to do? I think you've guessed it by now. Deploy an MQTT publish and subscribe architecture so each location publishes their own nominated data tags to their MQTT broker securely over an outbound persistent connection, either over cellular, Ethernet, or even the internet. And all security is managed in one place, the broker, so IT can get a handle on the entire system quickly and easily. Now this scenario is also applicable to SCADA systems. Sure beats building out proprietary SCADA radio networks. And that takes us now into our live demonstration where I'll show you how all the pieces come together. Now this demo is based on a real business case scenario involving wind turbines, which I've named in this case the tale of two turbines. Now we've written up this case study with our customer named SCADA Solutions, and you'll be able to link to this case study once you receive the slides as part of your participation and viewing of this webinar. It starts off with an interesting phenomenon that has occurred in the state of California. Renewable energy is proving to be too successful. What does that mean? Generation from renewables, including wind and solar, can be more than we might need at any given time. And if you generate more electricity than you can use, you have a problem with the grid. Remember, you can't store extra electricity. You must consume it as it's generated. So, grid operators responsible for keeping our electrical grid in constant balance are faced with a dilemma. Renewable sources of energy are generally not dispatchable, meaning you can't just turn them off and on. So they came up with a way to dispatch these energy sources by changing the price they'll pay for the generation. And when they really don't want any more energy on the grid, they'll change that price to a negative dollar value. You know what that means? You generate electricity when the grid doesn't want it, you pay them. Of course, the problem for turbine operators is these turbines generate when the wind blows. And these turbines have been in service for years. So the only economical course of action is to retrofit the existing turbines, making them smarter by joining the industrial Internet of Things. So let's take a journey on how applying the new features in EPIC might address these problems for turbine operators. Now here's a snapshot of my Opto turbine Groov EPIC system that I'll be demoing from. You see I have a model wind turbine here wired up to my EPIC for controlling and monitoring the turbine. I have two network interfaces connected. The yellow one here is to the corporate network here in the building. And the blue cable here is to my isolated OT control network where you can see I have an Allen Bradley Compact Logix PLC which is wired up to this stack light. Then the EPIC itself is mounted on an 8-module chassis with various I/O modules to control the turbine's on-off state, its speed, temperatures, and various other I/O. Now to see how this is all set up, I'll click this link here to navigate over to demo.groov.com on a special page created for this webinar and continue the demo from my browser. Okay, here we are at demo.groov.com, that public website I spoke about, and it's right there loaded up in my browser. And there's my live cam. I can see that the turbine is indeed running, and I've already got Groov Manage up on the screen. So if we're that turbine operator and we're looking to use something like Groov EPIC and its capabilities to connect to the turbines, well, one of the first things we need to do, of course, is connect Groov EPIC to all of the I/O. And to do that, we're going to go over to the Groov Manage product and start configuring I/O, configuring the system, and even accounts. So we're going to do that by clicking over here to my bookmarks and open up Groov Manage. There you can see I am indeed connected to the Groov EPIC box, and of course because I'm logging in from a PC, certainly on the same network, I still have to log in with a username and password. As I said, everything is secure, authenticated, and encrypted. And there I am. I'm on the Groov Manage home screen. The first thing I'll need to do is see how this thing gets on the network. So I click on System, and then I click on Network. And there indeed, there's my host name. Now this is kind of cool. With the new systems, I can connect to these devices by name now rather than IP address. And on Ethernet 0, indeed I'm connected automatically via a DHCP server on the corporate network, which has provided me with an IP address and all of my Ethernet settings. And then down here on Ethernet 1, which is the blue cable I described earlier, and this one is the one that's connected to my OT network, and the Allen Bradley processor is on there. I can see I set up a manual static IP address for that, and in this case 172.22.042 is the IP address for this Ethernet port. And that of course will be on the same subnet as the Allen Bradley controller is configured as well. Terrific. Now that I've got that done, I should probably set up some accounts for how people might be able to log into this device and use it. And here's where I've got all my accounts set up now. For example, here's the operator account, and I'll click on that and I can see I've got a username of operator. But in this case, the permissions afforded to this particular account is only Groov View. No other capabilities are allowed. And in this case as well, that Groov View is only an operator. In other words, this user cannot actually edit any of the Groov View projects or anything like that. But let's go look at the account I'm currently logged in, and that's Opto. And as you can see, I have all the permissions, including an API key that I can use to develop the application. Okay, terrific. Now let's take a look at the I/O. Now I've already wired up all the I/O, as you know, so now I just want to go and say troubleshoot, make sure everything is working properly. So the first thing I'm going to do is, well, first I notice that all my I/O is automatically configured on the device, and I'll click on an output. In channel 0, I have a digital output. That is my panel LED. So there's a small LED right on that plexiglass panel that I can turn on or off. So I'm going to click on it there, and you can see that I've got the name of the I/O point there, its state, and its quality. And of course, I can force the I/O point on or off and check to make sure that it's working properly. And indeed it is. So that's pretty cool. But what if it didn't work? So here's what I can do. Probably the first thing I'd want to check is the wiring. And as I mentioned before, I can simply click on the Info tab here, and yes indeed, there's my entire wiring diagram to confirm that I have this panel LED wired up properly. And also I have all the specs here to make sure that whatever it is I'm driving with this output meets the specs of the module. So that's pretty cool. We're going to go back to I/O, and let's take a look at another I/O channel. In this case, we're going to look at the panel temperature, which is a thermocouple I have wired onto the front of the panel. So there it is. It's currently at 70 degrees. I can see its name, its module type. I can see its values, the minimum and maximum, and so on. Now, this is another example of some of the smarts we have in these modules. If I go to configure the module, I can see here where I can change the name if I wish to, but also I can change the channel type. So let's say I decide to move to a type J thermocouple. I simply select it here and apply the changes, and I'm done. And you can see that this particular module provides an array of different thermocouple types and millivolt types, all right there at your disposal. Okay, now we have our I/O configured, we have our account set up, we're on the network, and we've set up our OT network as well. The next thing is the control strategy. How do we create the control strategy for this particular application? So for that, we're going to switch over to Windows, and I'll have Windows start up here, and I'm going to come down and open up Pack Control. So in Pack Control, as I mentioned in the presentation, is our free Windows-based development tool for creating control applications that run right on EPIC. And in here as well, I've got all of my local I/O points. They're all listed there, and there of course is my panel LED. Now earlier I also described that I can take various data points from my control program and publish them to an MQTT broker. So, which I/O points? I mean, in many cases, there's a lot of variables, other information in here that may not need to be publicly available. But in this case, I do want the panel LED to be published to a broker. And I also want to allow someone to change that from afar. So here's how I do that. I'm in my editing my digital point here, and I can see that I have an option to make public access available. And this would be making it readable, and I can separately determine whether I want that to be written to. So there may be I/O points like outputs that you want people to be able to see whether they're on or off, but not be able to turn them on and off from afar. And that's why we have two separate checkboxes there. Same thing with my panel temperature. That's down here in the tree. Once again, I'll click there, and I have the same access here. Now, a thermocouple is an input, so there's really no point and allowing a write capability, but the checkbox is there just in case. Now we're going to drop into the visual debugger mode here by clicking on debug up here on the top, and I can see that my control strategy is running. I'll go ahead and visually see that, yep, indeed, it's grabbing the spot price from another location and making a control decision based on whether the spot price is at the proper level to run the turbine, and in this case it is. Okay, we're in good shape here. I'm going to go ahead and get out of the pack control strategy and get back to my application. Okay, we've got our Groov Epic configured with our network settings, our accounts are set up, we've tested the I/O, and we've confirmed we have a control strategy up and running, and it's making control decisions based on a number of data points. Now the next thing we probably want to do is create a local Groov View interface. Now this Groov View interface will be any screens that will show on the face of the Epic controller, or to say a connected HDMI compatible display, as we described earlier. Also, any devices that may be on the same network as this Groov Epic, such as my PC that I'm connected to this right now. So how do we configure Groov View screens for the Epic? Well, that's pretty easy. We're just going to go over here to my shortcuts, and I'm going to pull up Groov Build. Now, Groov Build is the way that we build these screens that will be resident in the Epic device, and from which everybody that connects to the device will see that information. Same thing of what will show up on the face of the Groov Epic in that touchscreen display. So first things first, you can see I've got a number of different objects on the screen. I'm pulling back a lot of data points from the controller. I'm trending some items as well, and I have a whole series of gadgets here I can place on the screen and tie to many different tags that are all available to me as well. In fact, some of these tags, as you can see, are the same I/O points and same tag names that I've already created in the control program. So as I said earlier, this notion of a single source of tags is already evident right here in Groov View. Now I can create many different pages for different types of information. Here's a screen that shows the weather station, and I'll explain how I've pulled weather data directly into the system as well. And then another screen we've created to manage when the turbine should turn on or off based on the real-time spot price. Okay, those are all important screens, and these are basically if you're connected with a PC or on a monitor of some sort. But what's also important is creating the handheld screens. These are the screens that will be on your smartphone that's connected on the same network or on the face of the Epic processor. And same thing here, we've got many different screens I can adjust. I'll pull this guy down a little bit and set everything up just the way I want it. And then this will be the screen I'll actually see on the face of the Groov Epic. Okay, now that we've got that done, let's go ahead and file, save all changes, and switch to Groov View. Now what's happening is we're saving all these pages. They're getting downloaded directly into the Epic device, and then anything that's connected to that Epic will automatically get updated, including this browser here. So there I can see all my operating parameters of my turbine. I can see also that the spot price is currently at $22.99 and that its run price is at $19. So because we met the parameters, we're going to be able to run this turbine. Okay, the next thing I may want to look at is how we got to that spot price. So I'm going to come over here to that settings screen that I showed you earlier, and indeed the turbine will run at $19 for turbine 1. For turbine 2, it's $24, and they're both in auto mode right now. So that's pretty straightforward. I can also take a look at the weather. And there's my weather information. I've got a mix of some strings. I've got some floats that I'm using in these gauges, and I'm trending the data from the weather station directly. And I'll show you exactly how we brought this weather information into the system. Okay, so I've got everything working. This, of course, will work for PC panels, for HDMI displays, but what it looks like on the Groov Epic device is this. I'm going to switch over to this new page, which is going to have, again, the live video image, and yep, there we are. This is refreshing at about a 1 to 2 second interval, and I can see now I have this local HMI I just built directly on the Epic processor. Okay, so how did I get the spot price to determine when to run or not run that turbine, or perhaps even the weather data that I pulled in? That's the job of Node-RED. So I'm going to go over here to add Node-RED, and we're going to talk about how we're going to activate Node-RED here and its flows to reach out from this network device out to external services and collect data to make decisions, whether they be for control or for maybe just viewing on a screen. Once again, I'll come over to my bookmarks, and again, you can see here I'm running right from the turbine controller, which is the Groov Epic, and here's all my flows, and these are all executing right inside the Groov Epic device. Here's the one for the spot price. In this case, every 5 minutes, I'm formulating a request, sending it to the grid operator's websites to pull down an XML file. Actually, it's a zip file of which an XML file is inside. I'll convert that file to JSON, and I'll write the data directly to the pack. So now this is directly to the pack control strategy running inside so it can make decisions on spot price. Pretty straightforward. Every 5 minutes, it's going to go get the latest spot price and make a decision to run or not. Here's my weather flow, and every 15 minutes, I again go make an API call to a Weather Underground API service. I extract that data and put string data into a string table and float data into a float table so I can create those displays that we just saw. But what's more, and it was what I covered in the presentation, is that I can take all the operating parameters of this turbine, and if it's running, I will take the parameters every 5 seconds and write them to an Amazon database. Directly, it's just a standard SQL Server database running on Amazon. This one flow in Node-RED does the whole job. Now, once information is up on a database, then it becomes pretty simple to generate reports and see that time series data. In fact, I have a link just for that where I've used a very simple PHP page or a web page to go view that data. And here indeed, you're seeing the time series data, all time stamped, all the spot price information, the run price, everything is right there at my fingertips. So very, very cool for writing data to a database and generating some quick reports to see what it does. Okay, if that wasn't enough, imagine that a Groov Epic controller acting as a turbine controls device actually has its own Twitter account. And this one does, because Node-RED also supports Twitter and texting, text messages, email messages, any kind of messaging you want to do, you can do right within the Node-RED environment. So once again, I'll come over here and I'll take a look at my Twitter account, and we can see indeed that 4 hours ago this turbine generated at 2 minutes after the hour. So there you go, another alerting method using Twitter. So let's close that down. And there's one other thing I want to show you while we're here in Node-RED, and that is I spoke about Node-RED's capability to communicate with cloud platforms. Well, indeed, this is the flow for communicating to IBM Watson. There's the node for it, and I can see the nodes right over here on my palette. I just click and drag the palette out, move the data into that node, and instantly I'm writing this data all the way up to the IoT Watson platform. In this case, I'm doing it at a 15-second interval, and again, only when the turbine is on. Let's take a look. So I'm going to go over here and navigate to my IBM Watson IoT platform, and there we are. I'm already logged in under my developer account, and right here is Turbine Farm B, and you can see that 11 seconds ago, or no, now 2 seconds ago, I'm seeing all the operating parameters in IBM Watson. Now, why would I do that? Well, Watson has many capabilities to take this data over time and do things like machine learning, artificial intelligence, all kinds of capabilities within this platform. So we're simply taking the data and moving it up there on whatever frequency we desire and let the IBM Watson IoT platform go from there. Pretty slick and all built right into the system. Okay, so that's Node-RED. We're going to now move on to the next step of the demonstration, and that is, in many cases, you might need more than just what instrumentation you have connected to the turbines. Let's say maybe there's another PLC there, or within your plant, you've got other PLCs, or from Siemens, Modicon, and Allen Bradley, that you want to bring this information to, and maybe move it to a database, or a cloud platform, or just build screens for. Well, that's what we're going to do next. I'm going to show you how we actually use the Ignition Edge software embedded on this device, denoted by this green checkbox here, to connect to these PLCs. So once again, back to my bookmarks, and I'll go to the Ignition Edge software. Now, as you can see, once again, I am still connected to the Groov Epic controller, and I will sign in here. I'll click in, put in my username and my password. Now, once I've logged into the system, I'm now going to go over to the Configure tab right up here at the top, and then down the left side, I'll have a menu item for Devices. Now, this is the various drivers that are included in the Ignition Edge software. If I click on Create New Device, you'll see that I'll bring up a screen with all the available drivers I discussed earlier. So there's all your Allen Bradley, PLCs, your Siemens, and so forth. But in this case here, I just want to show you the configuration for, in this case, the Compact Logix 5370, and there indeed I am connected to it. And the way I connect to it is pretty straightforward. I simply come in here and give it a name and a description and an IP address. Now note, this is the same IP address space that I configured my second Ethernet port on the Groov Epic for. So this is my private OT network that nobody can access from anywhere on the corporate network. It can only be accessed through the Groov Epic. So once that's configured and I have a connection to it, now I'm showing connected and I can start working with those tags. So that's how easy it is to connect to a PLC. Now, I've got everything there at my location. So at this particular Groov Epic, I've got my view screens, PLC data. I'm getting data from weather services. I'm sending data to IBM's Watson. That's all terrific. But what if I want to gain access to that data from, say, a SCADA host or from some other location, as we discussed in some of those MQTT scenarios I provided earlier? Well, the next step is to add an MQTT broker. So here's where we're going to securely publish our data up to a broker, wherever that might be. It could be on site, it could be in the cloud, or whatever. I'll show you where that is for the Edge software. And we're going to come down here to MQTT Transmission. We're going to click on Settings, and we'll have a list of servers that I'll click here. And indeed, there's my server. And you can see it's communicating over SSL, so this is a secure communications to the only port open in the entire system, 8883. I have a username and password and a certificate I've used to confirm that I'm a valid user and a connector to that MQTT server. Now I can also use this to create new MQTT servers, and why would I do that? Because in the event one fails, I can automatically fail over to many other servers if I choose to do so. That makes the system very redundant and resilient to any kinds of failures. Once that's done, I'm all set. I am now publishing any nominated tags directly to the broker. So the next step is simply make use of that data in some way. So we're going to go to Add HQ View. So now I'm going to show you some screens that have already been created back here, and this is back at Opto 22 Corporate with this website, https://demo.groov.com. And there's the user and password to get into this site, and again, it's a public site, so you can see this at any time. Now, what I'm using here is Ignition and Groov. In this case, Groov Server for Windows on a Windows box with Ignition software, and it's subscribed to the MQTT broker. Any data that's being published is being subscribed to by this system. Let's go take a look at the live data. So I'll click on this link, and there it is. So we can see that now the price of electricity has gone up to $24.75, so now both turbines are running and generating juice for the grid. And I can see all my other stats here. I can see some information from my Allen Bradley Compact Logix. I can see the waveform. There is my live video, so I can see that indeed my turbine is on. I'm also viewing information from another Opto turbine Farm A, right over here on this screen. And there's even others here. Now, how am I able to view all of this data from disparate systems all over the world? Well, let me show you back on the architecture screen. This one is showing each of these systems are publishing their data to the broker, and the demo.groov.com site that I'm on now is subscribing to that data and allowing me to visualize everything that's going on. Now, once again, I'll click on live data to go back to that screen because I want to show you one other capability of the system. Now, normally you'd think I'm just going to subscribe to data and pull it all in so I can visualize it. But remember, these are two-way communications or bidirectional. So as any device publishes their data up here for me to see, it's also subscribing to any changes I might make. So there's a button right here, and it's called Alarm, and it's tied to the Allen Bradley Compact Logix tags. When I click that button, I'm going to publish a change up to the broker that will be subscribed to by this live EPIC controller here. It will bring that data in, send it to the PLC, and turn on the stack light. So let me do that now. I'm going to try to orient my screen just so I can see both, and I will click Alarm. And as soon as I do, it instantly comes on out here on this remote site. I click the button on demo.groov and it automatically turns on the live information out there on the remote site. Now, this is critical because I've been able to do all of this securely without knowing the IP address of the remote site or anything like that, and the performance is amazing. So I've got the simplicity of pulling the data in, I've got the security over TLS connections, and I easily have the kind of performance that would be required of a system like this. So these are the next generation type communications that are now available with MQTT and with Sparkplug. So again, these are a brief overview of the various devices that are publishing to the broker, and this is subscribing to it. And then I'll show you one other screen, which is kind of cool, actually two others. I'll come in here and look at remote sites. Now these are just other Groov EPICs and or Groov boxes that are publishing data to the same broker. This one here is the Opto building. We've got an aquarium here. Our own Ben Orchard has a solar panel on his, or a number of solar panels on his rooftop that he's publishing all the data from his solar panels. And then even my home here showing temperature and power usage, again being published directly from my home with no open ports to get to that data. And then finally, we have a screen that allows us to actually view the health of the message broker or the MQTT broker that is in the center of that diagram. In this case, I have 17 connected nodes and a bunch of devices on there, how many messages per second may be occurring. Remember that messages are only transmitted on change. So there they all are. All my information is readily available on a public site being published from all these disparate sources. So that's a quick overview of the Groov EPIC system using these next generation communication architectures, using Node-RED, using Groov View and Groov Manage to configure it all. And so our outcomes are simply that now we get to process data locally with no middleware really needed at all. And we've reduced our reliance on IT and lowered our costs. Plus, we're getting much better performance and we're getting security throughout the system. Now you can get the data when you need it, send the data whenever you want, own your own ideas, data, and the systems, and really take charge of your projects moving forward. That concludes the live demo and this webinar. For more information, please check out www.opto22.com, where you'll find a lot more information, including data sheets, training, documents, everything you need to learn more about how Groov EPIC can help you in your applications.